All right, well, hopefully you looked at number 4. You might have gotten stuck right away. But either way, let's talk about this and let's see if we can clear up any misunderstandings. First thing is if you were solving for x to the fourth, we would subtract the 16. And then we would take the fourth root of both sides. But remember the process we've had to do recently. If you want to find your solutions for x, you are going to think of this as negative 16 to the 1/4 power, which means step 1, let's get this in trig form. If you were to graph, here's your real axis, here's your imaginary, negative 16 would fall here, which means that in trig form, this becomes 16, because that's your distance away from 0, kiss, and then we would have this angle of pi. Now, don't forget about the 1/4 power here. That's crucial. So this is step 1. Step 2 is now to use de Moivre's. So we would get 16 to the 1/4 power, kiss, and then we're going to get this pi times 1/4. So 16 to the 1/4 power, that's the square root twice, is going to give us 2, kiss, pi over 4, and this is our first solution. Now, to find your second solution, we need to use this idea of equal spacing. So recall that equal spacing, we have 4 different solutions here, which means each solution is going to be 2 pi over 4 units away. Because our first solution is in terms of fourths, I'm going to leave it as 2 pi over 4. But this is, I'm going to abbreviate our equal spacing for each solution. So we're going to rewrite this as 2 kiss, and then let's take that pi over 4 and add 2 pi over 4. Our next solution is 3 pi over 4. I feel like we need to start. Our third solution is going to be 2 kiss, and then adding another 2 pi over 4 is 5 pi over 4. And then finally, our last solution is 2, stop moving, kiss, 7 pi over 4. I love it when this happens, when all of our solutions are those middle angles. This is really cool because then what you need to do is really just find the one like I've been doing, and then the rest of them just change the signs. So let's make sure we get this first one right. 2 cosine pi over 4 plus I sine pi over 4. We're going to get a root 2 over 2, root 2 over 2. When you distribute that 2, we get a root 2 plus root 2i, and that is my first solution. Now, because my second solution has the same ordered pair but is in quadrant 2, I'm going to change the x value. Oh, come on. But I'm going to keep the y value the same. This next answer is in quadrant 3, which means both the x and the y would be negative. And then my final answer is going to be in quadrant 4, which means x is positive, but the y is negative. So those should be your 4 different solutions for this original problem. Now, moving on to the next question, same idea. We want to start by getting that x cubed alone, and then we can take the cube root of both sides. So really, we want to think of this as negative 64i to the 1/3 power. Now, when we go to trig form, remember that this is your imaginary axis, and so we're going to think of it down here. So you're going to get 64 kiss 3 pi over 2, all to the 1/3 power. Now we can use de Moivre's, 64 to the 1/3 power, kiss, and then we have this 3 pi over 2 times 1/3. The 3's cancel. We end up getting 64 to the 1/3 power, which is 4, kiss, pi over 2, and that is our first solution. Now, from there, we can find our second solution, but remember, we have to use this idea of equal spacing. So this time, we're going to have 3 solutions because the degree is 3. So we're going to do 2 pi over 3 for each solution, And again, getting this in terms of 6 would be 4 pi over 6. And remember that this in terms of 6 is 3 pi over 6. So our next solution would be this 4 KISS, and then we're going to see 7 pi over 6. So you know, now my other dog is cleaning himself. And then we have the 4 KISS, and then when we add that 4 pi over 6 again, we get 11 pi over 6. So those are your 3 different solutions, but now let's get those in standard form. So pi over 2, if you guys remember, is going to be, let me just write it all out. This would be a 0, this would be a 1, so we're going to get 4i. With the yellow, oh, I didn't use that yellow, I used this one. We can think of this as cosine 7 pi over 6, I sine 7 pi over 6, 7 pi over 6, negative root 3 over 2, negative 1/2. So we're going to get this to be negative 2 root 3 minus 2i. And then with this last one, remember this wonderful relationship with 7 pi over 6 and 11 pi over 6. It's going to be the same ordered pair, but this time the x value will be positive, the y will stay negative. So those are your 3 solutions. Again, if you were to take that 4i and cube it, you're going to see that you're going to get the solution to work here. So this will be one of your solutions. And so on and so forth. So the next problem is worded a little differently, but same process in some ways. They are telling you what one of the 4th roots is. In other words, we've done this process, and this answer right here would be equivalent to this right here. So they want us to determine z, which obviously is how this started, because we're finding the 4th roots of z, and this is giving us one of the solutions. Which means if you want to find what z is, instead of taking this and doing the 4th power of this, since this is a root, we want to raise this to the 4th power. And that's going to give us what z is equal to. Now, unfortunately, we have to get this in trig form. So going to our complex plane, we can graph negative 2, negative 2. Okay, I guess we're going to do that, notability. Negative 2, negative 2. So if I said to find your r value here, we would get that it is negative 2 squared plus negative 2 squared, or 4 plus 4, 8. So we get an r value of the square root of 8, which again, we've talked about. You can simplify if you want to 2 root 2. And then your angle here, remember we're in quadrant 3, the tangent of theta is going to be negative 2 over negative 2, or 1, but a common mistake is people say pi over 4, but forget that we're in the 3rd quadrant. So remember that to be in the 3rd quadrant, we're going to use 5 pi over 4 for this. So to actually now get the answer for z, we're going to take what we just found, this 2 root 2 KISS 5 pi over 4, and we're going to raise that to the 4th power. So to do this, remember that we're going to take this 2 root 2 and raise it to the 4th power, and then KISS 5 pi over 4 times 4. So from here, we can take that 2 root 2, raise it to the 4th power by doing what we did before. Think of this right here as 2 to the 1st power times 2 to the 1/2 power. If you rewrite this 1 as 2 over 2, this is really 2 to the 3/2 power, but you're raising that to the 4th power. So you end up getting 2 to the 12 over 2nd power, right? Because think of this as 4 over 1, which becomes 2 to the 6th power. Over here, we're going to get KISS. These 4s are going to cancel, and we're going to get 5 pi as a result. So what you end up getting for this, 2 to the 6th power, well, 2 to the 5th is 32, 2 to the 6th is 64, KISS 5 pi. And then do they want us to find the actual value? We can keep going with this and then write this in standard form. So 64 and then cosine 5 pi plus I sine 5 pi. Well, if you remember, 5 pi is really the same thing as just pi, as is this. So we end up getting cosine of pi, which is -1, sine of pi 0. So we end up getting -64 as our value for z. Now, that really means that from the beginning, what we were asked to do for this problem, I mean, in other words, the original problem would have been find the fourth roots of -64. So it's equivalent to solving this. Now, from here, there's different routes you can go. One of the routes is we already have one of the solutions. Remember that this is technically one of the solutions in trig form. So if you already know one of the solutions is 2√2 KISS 5 pi over 4, if you want to find the remaining roots, which now we still have 3 of them left, you can use this solution right here. Or, second way of doing this is now that you know this, and that's really what the original problem was, you can go about doing this problem as you did these problems up here, where you go through that whole process and you get all 4 solutions. Either method works. I'm going to do this method since I already know the first solution. If I want to find the second solution, it's going to be 2√2 KISS, but then think about this 5 pi over 4. If we want to do equal spacing and we have 4 solutions, we have 2 pi over 4 for my equal spacing. My next solution then would be at 7 pi over 4. Now, notice that because this first solution is at 5 pi over 4, and that technically wasn't like the first one that we saw from 0, that was the one that was given to us. If I want to find my next solution, if I add another 2 pi over 4, I'm going to go over 2 pi and have to find what's coterminal. Keep in mind you can take that first solution and you can also subtract 2 pi over 4 in order to get 3 pi over 4. So it's kind of nice that you can use that and then also subtract one more time. And if you subtract one more time, you're going to get that 2√2 KISS and then pi over 4. So again, you can add 2 pi over 4, but then once you see that you go over 2 pi, you would have to subtract 2 pi and still would get those 2 answers. Now, we already know that for one of these answers, what this is equivalent to. We already know that this is -2 minus 2i, because that's what was given to us when we started. So from here, if you want to find the remainder of these, just think about changing the signs. If you're at 7 pi over 4, the x value is positive, but the y is negative. If you're at 3 pi over 4, remember that the x is negative, but the y is positive. And then finally, if you are at pi over 4, both x and y are positive. So those would be your 4 different solutions and the 4 different roots in total. So I'm going to stop this video, and then I would like for you, again, to try out these next 2 problems, and then you can watch the third video